Hey guys, I'm back in my workshop and I'm back on the Willis Farmers engine. And the cylinders are starting to look pretty good. But look, in this video what I want to tackle is a couple of 3D printed patterns. As I go with my project, I make more 3D printed patterns and I typically cast in batches. So I'll get to that now. After that, I want to show you how to use fixtures and jigs. Now, this is something that most model engineers tend to not do on their first sort of beginner's loco or beginner's steam engine because it looks like a lot of work. But it does save you tons of work down the line. So I'm going to show you how to use jigs and fixtures, and I'm going to show you how to drill incredibly accurately using these jigs and fixtures for all the components on the cylinders. Check this out. I'm at the point of the build where I need to do a couple of patterns and I need to do a few castings for the next batch of things that I'm going to machine. And typically this goes in stages as the build progresses because I have 7 flasks in total and it takes me about 5 or 6 hours, one day to mix up the sand and fill up all the flasks, and then I cast the next day. But I do want to show you some of the patterns and how they're going to fit into the actual Willis Farmers engine before I continue with the cylinders. The most interesting is always for me the chimney. Now, the problem with the chimney, and most of these chimneys of pretty much all of the locos above 3.5 gauge or steam engines that are sort of one inch to the foot and larger, is it's quite difficult to hold this in a home workshop lathe. The problem is the back end is bigger than the chuck or the spindle. So it's always easier to hold it on the smaller side of the chimney, but then the cap always gets in the way. So what I like to do is I split my caps. Now I'll get to how they go together in a second, but if you hold it like this and you machine from this end, then everything tends to work out because you got your taper and then you got your vacuum taper towards the end, and this goes in with no issues, and then your cap can be fitted and machined towards the end. What makes it a lot easier is the caps are typically a brass or a copper. A lot of the older sort of steam engines had copper. The newer ones or the display ones that the steam or the railway lines used to use were brass, but they were more for display. So typically what I do is I make the chimney out of aluminium so that I don't have a long piece of brass. So the center of gravity of any steam loco that I design is slightly lower, but the cap can be made from copper or brass. I always add a spigot to the cap so I can chuck it and I can machine the end, and then this will just be a press fit at the end of the aluminium chimney. So what I'm going to do is I've done 2 videos for all the patterns. The one video I'm going to put on Patreon, and that describes how I clean the 3D printed patterns, and it tells you, and I'm going to show you how to pin them together, how to put in your extraction points, and a couple of points on designing for casting. All of this is in my book, and I also have a calculator that's downloadable with my book on Patreon. But the video will be free to any member. Any free member can have a look at the video, and it will give you lots of tips on how to do these castings. But for this video, I'm just going to talk about the castings for the Willis Farmers engine and the next steps. So that's the chimney. A really cool casting is this gear casting. Now, one of the coolest things about 3D casting is have a look at the detail that you can put into this pattern. I mean, and also you can do both sides. A lot of guys only do one side of the pattern and then they make the back end flat because you're not going to see it, but you do see it on certain engines. This has got a star sort of configuration for all the webs on the inside, and all of these faces are drafted, so it's very easy to get out of the sand. Now, this is exactly how the original would have been. It would be very difficult to replicate this with a wooden pattern. So 3D printing is really one of the ways to go if you want to make your own patterns. And then again, this is a 2-part split pattern, and I explain on the video at Patreon exactly how to do this. So have a check, it's for free, you won't need to pay for it. One of the weird things that I'm doing very different on the Willis Farmers engine is the Smokebox I'm making a single casting. Now, normally what I would do is I would make a front plate and I would make a backing plate. I'd roll a piece of sort of nice piece of plate and I'd weld it all up and I'd end up with a nice smoke box. In this case, I'm actually going to cast this as a single component. And there's a couple of reasons for that. First of all, if I cast it as a single component, I can actually make it a lot heavier. And that's typically what you want with a traction engine. You want the front end a little bit heavier than the back end so that the front end doesn't pick up when you take away its speed. And I've changed the gearing on the Willis Farmer's engine to make it a little bit more fun for the kids in the street. What also does sort of make life a little bit easier is when you do the smokebox door, and incidentally, this smokebox door hasn't got the hinges or anything cast into it because the smokebox door would actually fit on the smokebox. The gear for the steering would come in the front, so you wouldn't be able to hinge it away. What you would typically need to do is you would need to pick it off like that. So there'll be a recess like the original, and then this smokebox door will sit inside the recess and it will seal really, really well. So this simplifies the smokebox for the Willis Farmer's engine quite considerably. And you'll notice, just for interest's sake, on all of my patterns, I have these sort of symbols written on the patterns. I typically have how large or how heavy the casting will be, because then I can work out how much I need to pour. And in this case, I'm not sure if I'm going to make it out of aluminium or brass. I have a feeling that I'm just going to use scrap brass or cast iron so I can make the front end a little bit heavier. And then this is the casting modulus, and typically the casting modulus I explain in my book, but let me give you a quick explanation for how that works, right? If you put this in the sand and you pour the molten metal in, everyone knows that molten metal has got a slightly higher volume than the frozen component, and as the metal freezes, the volumetric change sort of causes these casting inclusions all over in the pattern. Now, casting modulus is just a ratio of your volume to your surface area. So all the heat that gets extracted from the part that you're casting is through your surface area, and the volume is where you're going to end up with the issue. So if you have a high volume part with a low surface area, you're going to end up with voids all over in the casting. So that ratio sort of tells you when you need to start worrying about feeding and stuff like that. Now, what a lot of guys do in the home workshop is they guess. So they guess the size of the riser, they guess the size of the ingates, and so forth. And typically you end up with 2 or 3 scrap castings, and after the third one you realize what you're doing wrong, and then you make your riser bigger or your ingate bigger and so forth, and you end up with a good casting. What I did is I developed a calculator, and I used these ratios to determine when and what size risers and ingates you would need for each casting. So that takes a lot of the guesswork away. Now that calculator comes for free with the book on Patreon. So all that it does is that takes away the guesswork, and you're going to get it right the first time. So that's the smokebox assembly, all from castings. Another interesting casting is the bearing stand for the crank. Now, here's another little trick with patterns that I talk about on the Patreon video, if you want to go and have a look. Is this was typically a one-sided pattern, so the angle was on the one side, on sort of the right hand side, and on the other side the angle was on the left side, so it only had the one angle. It makes sense to duplicate this, so you double it on both sides. If that's still at the bottom, you only have one pattern for both components, and if you cast one extra component, you have a spare for both sides, and then after it's cast, you just cut off the side that you're not going to use. So this pattern is 3D printed, and I think it looks pretty good. So assembling this valve chest to the cylinders is actually a bit of an issue, because you do need to align the center valve spindle to the center line of the cylinders. So what I typically do is I map it to the side and then I draw the center line through the valves, and then those 2 points just need to match on the one side. Okay, that's pretty easy. Here's the issue. Once you line it up and you clamp it in the vise, this will move. Because you've got two surfaces that are sort of very, very easy to move around, you do want to fix them. So here's a really, really cool trick. What you do is you just put 1 or 2 drops of super glue, and you only really do need 1 or 2 drops. And then when you align it for clamping in the vise to drill your 2 holding holes. So I've drilled my 2 holes, the one straight through there to the other side, and then so those 2 will clamp for the rest of the holes, and I've aligned it up nicely. The nice thing about super glue is it comes off relatively easy. So now we can clamp using these holes, and we can drill the rest of the holes. So the next step is making the glands for the valve chests and for the cylinders themselves. Now, I haven't shaped these, and I'll show you now how to drill the holes, but typically shaping this is a 5-minute job. You don't need the milling machine to shape it. I'll show you how to do that with jigs. Just quickly, all of my glands are made from the risers from all of my castings. So when people say that these trains cost a lot of money, they really don't. This looks really expensive, the cylinder assembly, but to be frank, this was all made from scrap. These large caps were very, very large cylinders that I casted, so they were scrap. All of this was cast from scrap, and then even the valves are made from the risers. How cheap can that be? Typically, all the valve chest and the piston rod needs a proper gland to seal it. Now I ream my holes through, so I get a good seal anyway, but I still put a gland in because the originals had glands, and also as it wears, you tighten up your packing, and then you don't get any steam leakage from your cylinders, which of course you shouldn't. The problem is drilling these 3 holes for the gland is a bit of a trick, because if you drill the center hole and one of these holes are slightly to the side, then these aren't going to line up, and then the gland will only fit one way. It won't fit both ways. Another issue is you really want your 2 opposite glands to be identical and symmetric. Now to get that right is tricky because the holes are typically quite small and the middle's a reamed hole. But there is a nice way of doing that. All of my glands, I make myself a little drilling jig like this. And what I do is I drill 3 holes in line and I set it up on the mill. Nothing needs to be aligned. It can be whichever orientation you want. You clamp it, and as you drill 1 hole, you don't change feed in this direction. So then you drill 1, 2, 3 holes all in line, and you know that they're perfect. The advantage of this I'll show you now, but getting the distance from that center line to that center line is using stop gauges. I don't use my dial wheel on my milling machine. And if you use stop gauges the exact same way that you use stop gauges when you were doing the valve chest, you get excellent accuracy on those 3 holes. And then typically what you do is you just clamp this, you clamp the valve onto one of these jigs like that, or you clamp the valve onto the center hole like that, and then you just drill the 2 outside holes and you're good to go. The advantage of doing this is actually very, very cool. If you put these 2 together and you line up the center hole, you will notice that both outer holes line up perfectly. Now, how cool is that? To finish off shaping the glands, all that I do is I use engineering buttons, and all that is little cylinders that are bolted together with the glands back to back, and the outside gets filed. And that is typically a 5 to 10 minute job. It is way quicker than putting it on the milling machine and doing all sorts of fancy milling operations. So if you want a perfect symmetric gland, which is obviously what you want, what you do is you take it apart, you flip it 90 degrees, you put it back together. And this one you can see actually is very, very close. And just a little bit of emery cloth over the side will make this shine beautifully. I actually don't normally paint my glands. I leave them like this.